Question number 8. In the figure below, O is the center of the circle. Points A, B, C, and D lie on the circumference of the circle. Line AB is parallel to the straight line EDO, and the line FAE is a tangent to the circle at A. Angle FAB is equals to A degrees. Angle DOA is equals to B degrees, and angle DCB is equals to 70 degrees. So all the angles are indicated there, 70, B, A, all the points are indicated. The question is, determine the values of angle A and B. Determine the value of angle A and B. So you need to look at this diagram, this figure, very carefully. Establish all the properties that you can use to find these angles. This one being the center, the first thing. This is a radius. OD is the radius, and OA is the radius. So you notice that this one is an isosceles triangle, and you can let this angle, the base angles of this isosceles, to be x degrees. So let these to be x degrees, because this is a radius, this is a radius. Another property that you can see here, FAE being the tangent and AO being the radius, we need to recall the tangent radius property. So if this is the radius and this is the tangent is always perpendicular to the radius. This is very important. So we have the radius here, AO, and then you have the tangent. So this angle that is here, should be 90. So A plus this angle that is here, and this angle are given that EO is parallel to AB, OA acts as a transversal, and this angle B is alternate to this angle. So this B is equivalent to this because they are alternate angles. This one being EO is parallel to AB, so OA is a transversal, so B is alternate to this angle, and they are equal. So using again this property, the tangent radius property, you notice that when you take angle A and B, so angle A plus B should give 90 degrees. A plus B, this is a tangent radius property. So angle OAF should be 90. Then there is something else. Look at this triangle OAD. OAD, you have x plus B. This one should give 180 degrees. The sum of angles in a triangle. That one should give you 90 degrees or 180 degrees. Then there is still another property that you can use. Look at this cyclic quadrilateral ABCD. That one is a cyclic quadrilateral. What do you know about the opposite angles in a cyclic quadrilateral? Opposite angles in a cyclic quadrilateral should add up to 180 degrees. In this case, 70 plus this angle 70 is opposite to x and b. The angle at A is opposite, so x. So when you add x plus b, you should get 180. So 70 degrees and x plus b are opposite angles in a cyclic quadrilateral. So using these three, we can manage to use them and calculate the sizes of the angles that are not known, that is A and B. So let me use these x plus b, you get, so that will give 2x plus b is equals to 180 degrees. This one x plus b, 2x plus b is equals to 180. Then this one will be x plus b, this one, x plus b. If you take 70 to the other side, x plus b is equals to 110 degrees. So I've gotten this from x plus b is equals to 180 from this triangle here. Then this one, I've used these two, using these two. These are opposite angles in a cyclic quadrilateral. I've got these. So you can see this simultaneous equation. I can solve this simultaneous equation by eliminating b. So 2x minus x, you get x. B minus b, you get 0. So 110 minus 180 minus 110, you get 70 degrees. So x is 70 degrees. If x is 70 degrees, then it is possible to use the same expression and get the other angles. So if this is 70, so if that is 70, and this one is 70, so this is 70 plus 70, 140. So what angle is remaining? 40 is remaining to make it 180, the sum of angles in a triangle. So already we have b is 40 degrees. And the fact that we have x is 70, that is 140, then 180 minus 40, 180 minus 140, you get 40 degrees. Now what about a? A will be, we're going to use this one, a plus b is equals to 90. Already we have b, so we have a plus b is equals to 90. So having b as 40, a plus 40 is equals to 90, and therefore a will be 50 degrees. So we have obtained now the two angles. We have a 50 and b is equals to 40 degrees.